Hi guys, welcome to the next video in the topic about elements in the periodic table. This video is going to be focused on metals and non-metals, and we're going to go through some of their properties and how we would identify whether an element or a material falls into one of those two categories. So I'm going to start by quickly reminding you about where our metals and non-metals sit on the periodic table. So what we've got here is all of these ones that I've coloured in pink. They are our non-metals, and they sit on the right-hand side of the periodic table, above what I like to call the stairs. This line that I've drawn here that is a little bit thicker, that looks a bit like a staircase. So these are all of our non-metals. Our metals I've coloured in blue, and they sit below the stairs and to the left of the periodic table. And that is the position they're always put in. If we were to find any new metal or non-metal elements, they would go in either side of the periodic table and everything would be reshuffled a little bit to fit them in. So let's have a look at metals. So when we classify or group an element into our metals group, we classify them based on a set of physical properties. Okay, so we don't really look at their chemical properties that much, we look at what their physical properties are. So those physical properties include things like when you cut them, they're shiny. So if you think about coins in your pocket or in your purse, those are a bit shiny. If you were to clean them up, they'd look a lot shinier. Most of them are solid at room temperature. There is an exception. Mercury isn't, and that is why we used to use mercury in thermometers. Mercury is actually a liquid at room temperature, but it's pretty much the only one of the only metals that does that. They have a high density. So what that would mean is if you were to pick up a small amount of them, they would feel quite heavy for the size of the piece of metal that you've got. They're strong and malleable. That means you can bend them and they won't shatter or break. We use the malleability quite a lot when we think about hammering them into different shapes and what types of shapes we use them for. This one right here, the heat and the electricity, these are really important ones because these are properties that make them useful in our homes. So if you think about they can conduct electricity, we use them in wiring so that we have electricity that runs in our homes and runs through most of our electrical products. Without that property, most of the things that we use in our everyday lives that we take for granted would not work. They conduct heat. That's brilliant for things like your central heating system or for cooking. So if you think about when you turn on the heating, you've got radiators in your house. Those radiators are made from metal. If those radiators weren't made from metals, they wouldn't conduct the heat into the room, and so your room wouldn't get hotter. Cooking, you turn on your gas or your induction hob and it heats the metal pan, which then cooks the food in it. Without the ability for them to conduct heat, you wouldn't be able to do those things. They're sonorous. What that actually means is if you were to hit a metal like that. That wasn't the best example because I was using a plastic pen to do that with, but they would make a sonorous noise. And then we've got these three metals here. These three, iron, nickel, and cobalt, are magnetic. That means they will stick to a magnet. Now that comes in really handy if you're doing recycling, because when you are recycling things, you can actually use a magnet to separate them. Okay, guys, so all of these properties right here are ways of working out whether an unknown material is a metal or a non-metal. So if you have something that you're not entirely sure what it is, you could ask yourself questions like, is it shiny? Well, if you could, did it look shiny or not? Is it solid at room temperature? Could you connect it into an electrical circuit and the circuit would actually work? Things like that. So you could ask those questions and perform those tasks. And if it matched these things here, then you could say it's a metal. Okay, guys. So let's look at our non-metals. So non-metals again are classified by their physical properties, except this time they are pretty much the opposite of metals. So if you look, we've got dull when cut. They're mainly liquids or gases at room temperature. They have a low density, so if you were to pick them up, they would feel very light. Obviously, if they're a gas, you're going to find it difficult to pick up unless you've got them in a container, but they would still feel lighter. They're weak and brittle. Most of our non-metals would shatter if you hit them or drop them. They are poor conductors of heat and poor conductors of electricity. Now, this is actually pretty useful because what that means is they insulate against these. So, a lot of our non-metals are used to protect us. So, if you think about pan handles, they are plastic. Plastics are non-metals. They don't conduct heat. So if you put the pan on the hob and you pick it up by the plastic handle, you are not going to get burnt compared to if you picked it up with the metal pan. We also put them around wires. So if you think about wires for your TVs and stuff like that, they're normally coated in rubber or plastic. And again, that is because they can't conduct. And so what that would mean is the electricity can be running through the wire. And if you were to pick it up and it was the bare wire, you're likely to get electrocuted. But if we've got this rubber or plastic around the edge of the wire, when you pick it up, the electricity can't pass through that, so you won't get electrocuted. So a lot of the time you will see metals surrounded by non-metals in order to protect us for whatever use we're using them for. If we were to hit them, again, unlike with a metal where it would make a clinging noise, this one would not. It would sound very, very dull. And so you would be able to tell straight away if it was a metal or a non-metal when you hit it. Okay, guys, again, like I said, if you ever have a material that you are unsure as to what it is, you can ask yourself these questions. When you cut it, was it dull? How was it weak or brittle? Did it smash when you hit it? Can you put it into an electrical circuit and it will actually work? If it doesn't answer those questions or it comes up with these answers here, then you can classify it as a non-metal. Okay, guys, thank you for listening today. And I will be back soon with some more stuff on metals and non-metals.